Wind power is an important source of renewable energy. In this presentation, we'll look at how wind power produces electricity for the grid. The most important parameter for wind power is, of course, wind speed. And looking at the wind power class chart, we can see that the higher the class, the higher the wind speed. So we look at this chart, it ranges from class 1 to class 7, and as that goes up, then the wind power density and watts per meter squared also increases, and the corresponding wind speed increases. So if you want to have good conditions, looking at the chart, you probably need wind speeds, average wind speeds, to be roughly 17 miles per hour. This means the average wind speed, not the wind speed at any particular point in time, but the annual average. At any location, there is a variation in wind. That is, if you have a high average wind speed, there's also periods where the wind speed is low, and there are other periods where the wind speed is very high. So if you look at that distribution, there's no place where the wind speed is always at a single high value. There's a range of wind speeds. This means then that a wind device that's catching that energy is going to have variable output. This is one of the realities, or one of the problems, that you have to deal with when you're converting wind to energy. There's a variation in wind. This wind speed variation isn't just from hour to hour, so there isn't just a range during a given day. There's also a seasonal variation. So there are some seasons, particularly when you think of a windy period, you would think of springtime be windier than, say, summertime. So there's a variation in wind speed. The good news from the point of view of capturing this wind power is that wind speed, like other properties of the weather, can be predicted. And so you can deal with this when you're trying to capture energy from wind. Although there are many wind turbine designs, the most common and the most efficient wind turbine is the horizontal axis 3-bladed wind turbine. And that's what we're looking at in this picture. This is the most efficient wind turbine, having efficiencies around 40%. So when you think of the efficiency of a wind turbine, typically 40%, almost always of this design. And for large-scale energy production, it's necessary to have many of these, sometimes hundreds of them in one location, or spread over a location to make a wind farm. Unlike a wind turbine you might have at home to produce a little bit of residential power, a commercial size wind turbine is going to be very large. So here we're looking at 300 feet or more in height. And most modern wind turbines produce a great deal of power. Say they're 3.6 megawatt machines. So a few megawatts would be typical of a big wind turbine. Wind turbines have several components. Obviously, there's a tower that holds up the body of the wind turbine, called the nacelle. There are the wind turbine blades, or the rotor, also called rotor blades. And then there is, on the very top of it, there is a directional device to tell which way the wind is blowing, so that the wind turbine can always point into the direction of the wind. A big wind turbine like this would have protection against very large wind speeds, where this would shut down at very large, dangerous wind speeds. A single wind turbine will have a power rating of 3 or 4 megawatts. 100 wind turbines would therefore have a power rating of 300 or 400 megawatts. So in order to have a total power output comparable to a large coal-burning power plant. 100 or 200 wind turbines are necessary, and they form a wind farm. However, unlike a coal-burning power plant, the impact of the wind farm on the environment is quite minor. So here we're looking at a wind farm, and you can see that underneath the wind turbines, there's room for cattle to graze, for example, or crops to be grown. This is a picture of wind turbines at a small wind farm in southern Vermont. Here's a question for you. Why are the blades on these wind turbines black? Every other case we've seen wind turbines, the blades haven't been black, but here they're black. What do you think? Well, the answer actually, as many of you would have guessed, is that the black blades allow these turbines to shed snow loads. So the black blades heat up in the sun and allow snow to melt off the wind turbine blades. Two things are needed for successful wind energy production. One are good wind turbines, and the other is good wind. We take a look at this map, we can see that there are some places in the United States where the wind is very good, and other places where the wind isn't very good, where you wouldn't want to have a wind farm. So along the New England coast, in the mountains of New England, up through the Midwest from North Texas to North Dakota, and then in the mountain west, these are very good places for wind. So if you were going to have a commercial wind farm, you'd want to have it at one of these places for good wind. Once again, the best places in New England would be along the coast or in the mountains of New England. We look at Connecticut, we can see that the best place for wind in Connecticut is offshore. So in the Sound would be a good place. Not so good in most other places in Connecticut. Connecticut just doesn't have a good wind resource. It doesn't mean that you wouldn't put up a wind turbine for your residential use in some areas, but you probably would not put a commercial wind farm anyplace except off the coast. And off the coast there would be problems with aesthetics, that some people would not like to see a big wind turbine out in the Sound, or a big wind farm out in the Sound. Now, looking here at this wind map for Massachusetts and also south of it, of Rhode Island and Connecticut, we can see that even though there are some good wind possibilities in western Massachusetts in the mountains, that by far the best wind resources would be offshore. And these are the areas shown here in pink and purple and red. And in Massachusetts, looks like one of the best places would be between Cape Cod and Nantucket. And that's the location of a proposed site for the Cape Wind Project. The other good places, if you look down in Little Rhodey, off the shore, there's Block Island, and the outside of, that is the ocean side of Block Island, looks like another very good site. This photo shows the Block Island Wind Farm, which will be, when it's completed and operational, the first offshore wind farm in the United States. And this is off the southeast corner of Block Island, off the Rhode Island coast. The 5 wind turbines we see here are each about 6 megawatts. So this is a 30 megawatt project. And it will provide electricity for the island, and it will connect up with a transmission line going to the Rhode Island shore, which is not all that far away, those of you who know this area well. What's particularly important about the Cape Wind Project is that this will be the first offshore wind farm in the United States. There are quite a few offshore wind farms in Europe, but this would be the first one in the United States. The other thing about this that's pretty clear from the maps we've shown is that this would create a renewable energy resource, wind power, in a location very close to a high population center. And if it's the beginning of a series of wind farms that produce energy for New England in a beneficial way, this could be a very good thing. There are some environmental issues related to wind. One is cited by many people as visual pollution. So as you can see in this slide, off to the horizon, this is what the wind farm in offshore from Cape Cod, the Cape Wind Project, would look like from the beach. And there's not much visual pollution, but for some people there is. And that's an issue that wind has to deal with. Some people don't like the looks of wind turbines. Other people like them or don't mind them. The other issue for wind turbines, I consider this to be a more serious issue than the aesthetic issue, is bird and bat mortalities. So the problem is if wind turbines are built in a place where it's in a migration path for birds, or it's built close to a bat cave, then there could be large numbers of mortalities. So like any other project that's going to be outside, siting is very important, and a careful study of the environment is necessary. An environmental impact statement is necessary. So this is an issue. I think it's an issue that generally can be successfully dealt with. People who build wind farms are doing this to make money. And in order to induce people to build wind farms in desirable location, there is a production tax credit. It's 2.2 cents per kilowatt hour for electricity produced by a wind farm, and it applies for a new wind farm for 10 years of its life. This has been a very important incentive for getting people in the United States to build wind farms. And this is something that Congress passes every year, and almost every year threatens not to pass. So this kind of incentive system for wind farms is very important. So the bottom line for the U.S. is shown here in this table. The current U.S. wind capacity is about 75 gigawatts. That's equivalent to 75 nuclear power plants. And this is a production of about 4.5% of U.S. electricity. The target for 2030 would be 300 gigawatts, equivalent of 300 large nuclear power plants. And this would produce about 20% of U.S. Electricity. This seems very doable because we have great wind resources in the United States. Building wind turbines is cheaper than ever, and there's a great drive and need to do this.